In this video, I will teach you about parametric equations. With parametric equations, instead of having one equation that shows the relationship between x and y, we write two separate equations showing x and y as a function of a third variable called a parameter, in this case t. Let's start off with some notes. With parametric equations, x and y are each written as a function of a third variable called a parameter, usually using the letter t. For real-world problems, this t often represents time. The parametric relationship can either be expressed as a set of functions, like x equals some function of time and y equals some function of time, or as endpoints of a vector like this. This is called a vector-valued function. So here's an example of a parametric equation. X is t plus 3 and y is negative t squared. Let's evaluate this function when t equals negative 2. At negative 2, x will be negative 2 plus 3, which is 1, and y will be negative 2 squared, which is 4, and then the opposite of that, so negative 4. In other words, at t equals negative 2, we get 1 comma negative 4. And that point is right here on the graph. Now let's evaluate the parametric equation at t equals negative 1. At negative 1, x is negative 1 plus 3, which is 2. Y is negative 1 squared, that's positive 1. And then the opposite of that will be negative 1. So we get the point 2 comma negative 1. That's right here. What happens when t equals 0? Well, in that case, x is simply equal to 3, and y will be 0. So we get the point 3 comma 0, which is right here. Similarly, when t equals 1, x is 4, y is negative 1, so we have the point 4 comma negative 1, which is right here. And finally, when t equals 2, we get the point 5 comma negative 4, which is here. By the way, notice I am respecting this domain that we were given. That's why I picked values of t between negative 2 and positive 2. Now, if we had simply been given y as a function of x, like we're used to, we would have gotten a parabola that went through these points like this. But parametric equations give us something extra. We know that when t was equal to negative 2, we were at this blue dot. And then when t was negative 1, we arrived at the red dot. So we get this directionality that we don't get without parametric equations. We started at the blue dot and we moved towards the red dot. From there we went to the purple dot and then the green dot, and we ended at the orange dot. So parametric equations give us this directionality. It's like a flow, almost an animation. Here's another parametric equation. This time x is 4 sine t and y is negative 3 cosine t on the interval from 0 to 2 pi. We have 2 pi, not 360 degrees, so our angles will be measured in radians. When t equals 0 degrees, we are right here on the unit circle. Remember that sine is the y value and cosine is the x value on the unit circle. So when t equals 0, x is equal to 4 sine 0. Sine of 0 is 0, so x will equal 0. Y equals negative 3 cosine 0. Cosine is the x value, and right here that is 1. So we have negative 3 times 1, or negative 3. So we get the point 0 comma negative 3, which is right here. Let's see what happens at t equals pi over 2. Pi over 2 is right here on the unit circle. X will equal 4 sine pi over 2. Sine is the y value, which is 1. So this is 4 times 1, or 4. Y will equal negative 3 cosine pi over 2. Cosine is the x value, so that's 0. Negative 3 times 0 is 0. So we get the point 4, 0, which is right here. Pi is right here on the unit circle. When t equals pi, x will equal 4 sine pi. The sine of pi is 0, so x will equal 0. Y will equal negative 3 cosine pi. Cosine of pi is negative 1. Negative 3 times negative 1 is positive 3, so we get the point 0, 3, which is right here. 3 pi over 2 is right here on the unit circle. So when t equals 3 pi over 2, x will be 4 sine 3 pi over 2. Sine of 3 pi over 2 is negative 1. So this is 4 times negative 1, which is negative 4. Y will equal negative 3 cosine 3 pi over 2. The cosine right here is 0. So negative 3 times 0 is 0. And we get the point negative 4, 0, which is right here. 2 pi lands at the same place on the unit circle as 0. So the sine of 2 pi and the cosine of 2 pi will be the same as the sine and cosine of 0. So we will get all of the same values that we got when t was 0. So we get the same blue point. The curve that we have been plotting is an ellipse, and without parametric equations, we would have written it like this. But this equation tells us nothing about the flow. We know nothing about the directionality. For that, we needed parametric equations. Parametric equations give us the additional information that we started here at the blue dot at t equals 0. From there, we went to the red dot, then the purple dot, then the green dot, and then back around to the blue dot at t equals 2 pi. Let's get our calculator ready for parametric equations. First, click the Mode button, and we will switch to parametric mode. So here's the Mode button, and then right here it says Function versus Parametric. This will cause some changes compared to what we are used to. If you click on the Y equals button, you will notice that x and y will be written as functions of t. And if you click on the Window button, instead of the usual x min, x max, y min, y max, we have this additional parameter for t. So let's use our calculator on example 3. Here's another way of expressing a parametric equation. It just means, of course, that x is equal to 3t, while y is equal to 9t squared plus t. So let's type these into the calculator. So x is 3t, while y is 3t squared plus t. Next, let's adjust our window so that t goes from negative 10 to positive 10. So t min will be negative 10 and t max will be positive 10. Remember, x equals 3t. So x at negative 10 is negative 30, x at 0 is 0, and x at 10 is 30. So this is our x min, and this is our x max. Y is 9t squared plus t. Y at negative 10 is 810, y at 0 is 0, and y at 10 is 910. So this will be our y min, and this will be our y max. So let's go back to the calculator, hit the Window button, and make those adjustments. T-step controls how fast the graph is drawn on the calculator. At t equals 1, hit graph, and you see it's graphed almost instantly. So I like to change this to something more like 0.1. Hit graph again, and you can see that it was drawn a little bit more slowly. For parametric equations, I like to make one other adjustment. If you go back to the y equals area, let's change this line right here. So use your left arrow, go over here, hit enter, and I want to change the line mechanism to this one. So go ahead and go down and hit OK. Let's hit graph again and notice the directionality. Alright, with that option you can really see the flow of the graph from left to right. For our notes, let's make a sketch of what we just saw. I need to change the scale so the graph will fit. For the x values, I'm going to multiply by 10. So each number will be like 10, 20, 30, 40. On the y-axis, I'm going to multiply by 100. So this is 200, 400, 600. When t was equal to negative 10, the x value was negative 30, and the y value was 890. So using my new scale, negative 30 will be here, and 890, so here's 800, here's 900, so almost 900. When t was equal to 0, the x value and the y value were both 0, so that's going to be right here. And when t was equal to 10, x was 30, and the y value was a little bit more than 900, so right about there. We know this is going to be a parabola shape, so I could sketch it right now, but if we go back to the calculator and use the table feature, so second table, we can get a few more points. So for example, when t is 5, x is 15, and y is 230. Alright, so let's squeeze that in there. So let's do an x value of 15. It's going to be right here. 230 is going to be, somewhere about like this. Similarly, when t is negative 5, x is negative 15, and y is 220. That's right about here. So the curve that we are sketching is this parabola. But thanks to parametric equations, we can also tell the directionality. On the graphing calculator, we saw that the curve is sketched from left to right, from the blue dot down to the red dot, and then back up to the purple dot. But even without the graphing calculator, the parametric equations told us that when t was equal to negative 10, the x value was negative 30. So that was over here on the left. And then when t was 0, we were at an x value of 0. And when x was 10, we were over here at an x value of 30. So even without the calculator, we would know the directionality is going from left to right. And we will indicate the flow with little arrows on the graph like this. For example 4, let's make a table of values to get us started. I see that the domain goes from negative 10 to positive 10, but I also see that we have a 1/3 t in here. So I'm going to pick values of t that are divisible by 3, and negative 9 to positive 9 will get us very close. When t is equal to negative 9, the x value will be the opposite of that, which will be 9. Now the y value will be t squared, so negative 9 squared, that's 81, minus 1/3 of negative 9. This will be 81 plus 3, which is 84. At t equals negative 3, the x value will be positive 3. Y at negative 3 will be negative 3 squared minus 1/3 times negative 3. So that's going to be 9 plus 1, which is 10. When t equals 0, x will be 0 and y will also be 0. When t is 3, x will be negative 3. Y at 3 is 3 squared minus 1/3 times 3. So that's 9 minus 1, which is 8. And when t is 9, x will be negative 9, and y will be 9 squared minus 1/3 times 9. So that's 81 minus 3, which is 78. Let's change the scale a little bit so that the points will fit on this graph. We will let the x values just stay what they are, But let's multiply these y values by 10. So here's our first point at 9, 84, and here's the next point at 3, 10. Next we have a purple point at 0, 0, followed by a green point at -3, 8. And finally this orange point at -9, 78. So the curve looks like this with directionality from right to left. Just for fun, let's type this parametric equation into our graphing calculator. Let's adjust the window. The Tmin and Tmax are still -10 and +10. The Xmin and Xmax will also be -10 and +10. The Ymin was 0. The Ymax was like 84. I'm just going to go ahead and put in 100. And let's hit graph and see what we get. The animation showed the directionality from right to left, just like we thought. Let's do one more example, and let's make it a trig example. Notice that 3 pi is approximately 9.4. Here we have values of t going from -10 to +10. But if we graph values of t from -9.4 to +9.4, that will be pretty close to the same thing. So let's use values of t from -3 pi to +3 pi. -3 pi is right here on the unit circle. The cosine of -3 pi will be the x value, which is -1. So we have -1 for the x value. The y value is cosine squared, so y will be -1 squared plus 1/3 of the cosine, so 1/3 of -1. Well, that's just going to be 1 minus 1/3, which is about 0.7. -2 pi is right here on the unit circle, where cosine is 1. So the x-coordinate will be 1. The y value will be the cosine squared plus 1/3 of the cosine. So that's just going to be 1 1/3. So let's call it 1.3. -pi is right here on the unit circle, but that's the same place as -3 pi. So we will again get -1 for x and 0.7 for y. At t equals 0, we are at the same position on the unit circle as we were when t was -2 pi. So this is just going to repeat. So this curve just oscillates back and forth between -1, 0.7 and 1, 1.3. For more detail, let's use the graphing calculator. I've typed in the parametric equations. Notice that the calculator is in radian mode. Let's adjust the window. So Tmin and Tmax will still be from -10 to +10. Remember that the x value was simply cosine of t. Cosine oscillates between -1 and +1. So that's my x min and my x max. The lowest y value that we saw was 0.7 and the highest y value was 1.3. But we don't actually know how low and high the y values could get. So let's give it a little bit of breathing room. Let's let y min be -1 and we'll let y max be +2. I am letting t step be 0.05 to slow down the animation. Let's hit graph and see what we've got. Okay, so the graph is oscillating from left to right along a curve that looks like a parabola between -1 and +1. You can't really show this with arrows, so I'm going to tell a little story. The curve begins from left to right, from -1 to +1. Then it travels from right to left, from 1 to -1. And it repeats this pattern 3 times.